Warahmatullahi wabarakatuh, and a very good afternoon. In the next 1 hour, we are hosting two great speakers today who are respectable in the works they do on sustainable development goal, especially in relation to getting community participation in their programs. My name is Rosita Shapawi. I am your host and moderator for today. I'm a professor at the Borneo Marine Research Institute of University Malaysia Sabah. My expertise is on sustainable aquaculture involving different aquatic species, including seaweed, which is our topic of one of our topic of interest this afternoon. I would like to thank the Department of Architecture, Faculty of Design and Architecture for organizing this webinar series number 6 on SDG6, water and sanitation. The webinar series on SDG6 is co-organized by UNEP Malaysia from Global Wastewater Initiatives Awareness Program with University Putra Malaysia. I welcome everyone who are here today. A little bit on the background of this program. The objectives are to increase awareness on importance of ocean quality preservation in promoting sustainable livelihood for coastal communities, and also to share culture-based technologies in the area of sanitation to remote settlements. In each series, we arrange and recommend speakers from among members of the Global Wastewater Initiative Awareness Program and pilot project partners from Malaysia. Today is the 6th of the 9 webinar series planned for the year of 2021 under the SDG6 title. The webinar series recognizes the partners and also supporters for SDG6, and University Malaysia Sabah is proud to partner in this program together with the Malaysian Industry Government Group for High Technology, or known as MITE. The webinar series is actually also part of the 50th celebration for the establishment of University Putra Malaysia. So, ladies and gentlemen, please be informed that all sessions is recorded for case analysis of the United Nations Environment Program. So, without further ado, I would like to introduce to you our first speaker this afternoon, Associate Professor Dr. Puria Pasbah from Monash University, Malaysia, who will speak about the making potable clean water from contaminated water resources. Okay, a brief introduction, background of Associate Professor Dr. Puria. He is a chartered mechanical and material engineer, a researcher, lecturer, and also innovator. In his education, he covered all different types of engineering material, such as ceramics, metallurgy, and material selection, and polymer composites. His research interests concern the preparation, characterization, and modeling of nanomaterials and polymer composite for various applications, including water filtration, built environment, high-impact composite and polymer coatings, automotive and aerospace, 3D printing, biomaterials, and self-healing. Besides the innovation engineering related projects, where he helped different companies on their R&D projects, he is also interested in the entrepreneurship development topics and co-founded 2 startups. One is about fibrous water filters, and another one on a smart agro-tourism farm. So I would like to remind the audience again to write in the chat box if you have any question for the speakers. We will respond to you at the end of the session. We will gather all the questions later during the Q&A session. So I think I would like to welcome Dr. Puria. The floor is yours. Thank you.
Okay, thank you so much. I had some difficulty too. Thanks for your introduction. It's nice to be here. So I will go to my slides. Uh, Okay, so yeah, as Dr. Rosita mentioned, I'm going to talk about making portable clean water from contaminated water resources. So basically, this project is a project that we have been working on it in the past 10 years with different final year project, PhD students, and also colleagues from different countries and different universities. So we started from the basics of the water filtration, and then we found that although we have a lot of advancement in the technology of the water filtration, but we are still having a lot of problems about the water filtration and giving clean water to the people, not only in the normal scenario, but also in the disaster cases like flooding, in different countries, and not only in poor areas, but also in developed areas and countries like even US or some parts of the even Australia, that whenever there is a flood or there is a disaster, then still people they don't have access to the clean water. And it's very crucial to give the clean water to the people, especially in the first few days of the disaster. So in this way, we are trying to kind of relate the disaster management and also basically the technology of the clean water. So you know that even the normal scenario, not even in the disaster management perspective, 1 in 7 people they don't have access to the clean water, and when it comes to a disaster, it will be even worse. And of course, when you go to the poorer areas, especially in the Southeast Asia, that the countries that we are working with them and we are living in it, we are having a lot of problems. For example, in countries like Cambodia, Sri Lanka, so these are the countries that we went there, we studied their problems, and even the contamination that is existed in their water. And it's not only about the drinking water, it's also about the sanitation water. So how we can give just a clean water for washing purposes to the people, for just taking a shower sometimes, or sometimes they to clean their food. If I can tell you just one comment about what is found globally, that more than 10% of the people in the world, they consume the food which is contaminated by the water, by a water that is contaminated by VOCs, the volatile chemicals, or some types of viruses or bacteria. For example, in case of Sri Lanka, we found that because the country, or even Bangladesh, the country was exposed to a lot of textile companies, then the rivers in the country are contaminated with the arsenic. So filtering the arsenic from the water, from the river water, is very crucial. So when you go to different places, we have different specific local problems. But of course, the whole problem is a very global challenge. Another example is in 2018, for example, in Puerto Rico, there was a flood and storm. And in the first few days of the storm, they got a lot of mineral waters from the US. So US could bring a lot of mineral waters for the people in Puerto Rico, so they could have access to those mineral waters. But because the roads were affected, people couldn't go and access to the mineral waters even. And then these mineral waters were still there until last year. I don't know about now. So they couldn't use tons of liters of the mineral water that provided to them. And unfortunately, many people died in Puerto Rico because of not having access to the clean water. So, and you can see that this is very close to US, which is very developed country, and then they still couldn't bring and distribute the mineral water to the people. So that's why, although there are a lot of new technologies, but the problem is still a big problem for everywhere in the world. And of course, the problem is existed, and we focus on this problem in Southeast Asian context. So these are some of the pictures that done by Prof. project in Malaysia. So the types of the technology that Malaysia is providing for the people in those areas to have access to the clean water, at least for the showering and sanitation and washing the food. But of course, this can be advanced in a way that to go to the clean water and drinkable water. The problem is, unfortunately, the problem is very bad in Sri Lanka. Whenever there is a disaster, you see how people they are trying to collect the water and then go back home, and then using some of the very traditional methods to filter the water, so at least they can get some water in the first few days to basically to drink and to wash their foods. We try to focus on Sri Lanka and Cambodia. I'm going through to the Sri Lankan context, so you can see that we try to see what is happening in the Sri Lanka. I'm not going to too much details on this. So we try to collect samples from different places in Sri Lanka. As you see in this picture, so we focus on the Ginaruba area, and then we tested and analyzed the raw water samples by using the ICP, the mass spectroscopy. So we wanted to see what types of contaminations we have in the water from different places in that specific area. And later we wanted to, we used our membrane, our tissue, which we call it a nanofiltration membrane, if I can make it simple. We use those membranes into putting it into a 3D printed filter holder, and then this is an example of the clarity and quality of the water that we go from A to B and C. So it's like 2 times filtration. And of course, so this is at the left. You can see that we are using the normal, if you would like to call it like Coca-Cola or PET bottles, and then this is the filter holder, and the filter, the tissue, which is look like the face mask, it goes inside that white filter holder. And then we use these membranes, we roll these membranes, like a few layers of these membranes, they go, and then they basically filter the contaminations, the bacteria, the virus, the normal dirt that you have inside the river water, because we are using the river water as a sample, as a basic first water that has to be cleaned. So the porous structure of this membrane will be used to remove all of those bacteria, virus, and contaminations. If you can see this video, so this little holder goes inside the bottle, and you can see a dirty water inside the bottle. So this is the quality of the water that we are producing. And then what happened is, after we take this water, we send it to the different agencies or to check the quality of the water. And so far, we are in a very good level of the high quality water, drinkable water. But of course, we are making new prototypes in order to double check all the aspects, all different types of contaminations, including fluoride, including arsenic, including benzene, and so on. So there's a list of different types of contaminations. And then we are filing a patent on this. So once we done all of these, then we are sure that, okay, then we are able to produce a very high quality water. But as I told you, and I showed you the picture for Puerto Rico, distribution of these also into the disasters area, into the affected areas are also important. So we are trying to use a specific platform like a drone that can go, because probably during a disaster, there is no road, there is no transportation is available to the people, because these membranes, these filters are very light. So a drone can go there and distribute a filter to the people, and so they can use any water, any river, even if it is full of the dirt and mud, so to have access to the clean water for the few days for the first few days, until a real help can reach to them, and so the roads are open. There are a lot of, you might ask, okay, how about the already existed technologies? So yes, there are a lot of same technologies are available in the market, but then none of them are as cheap as what we have, and we are trying to reduce the price, because why? By having all of these technology, we are still having this problem because it's very expensive. So the target should aim to reduce the filter price to even less than $1, until we can basically encourage the NGOs and UN societies, related societies, that to buy these filters from the manufacturer, so they can distribute to the people in case of a disaster. And then the capacity that we can filter, we can filter up to 1,800 liters of the water using one of these filter holders. This project is a very ongoing project for the many years. There are a lot of people are involved, which we couldn't put the pictures in this slide. If I have to do that, so it will be like more than maybe 50 people, because this is a very long project. So this is a collaboration between 3 different institutes: Monash University, Srintech in Sri Lanka, and Newcastle University. So thanks for listening, and if you have any questions, please let me know. I hope I was on time.
Thank you so much, Dr. Puria, for following our time limit. You are very sharp, yeah? We still have a few minutes actually before your end of your slot. If you have any question, just put in your in the chat space. We will respond to that later on. So I think we will move to our second speaker. Our second speaker is Professor Dr. Suhaimi Muhammad Yasir. He is a research fellow and former unit head of Seaweed Research Unit, Faculty of Science and Natural Resources, University Malaysia Sabah. Professor Suhaimi will speak about traditions and challenges of seaweed farming in Sabah. Professor Suhaimi has developed a management system called Mini Estate System for seaweed farmers to manage the farm efficiently and improve their livelihoods. Prior to this achievement, he worked as research officer in the Agriculture Department of Sabah and Malaysia Cocoa Board before joining the Faculty of Science and Natural Resources at UMS. He is an expert in biochemistry and has been working on developing seaweed farming system and post-harvest processing since. So before we listen to Professor Jaime about modernizing seaweed farming, again, I would like to invite the audience to write in the chat box, yeah, if you have any question for both our speakers. We will respond to the question later on during Q&A session. So the floor is yours, Professor Suhaimi. Thank you.
Okay, thank you, Prof. Rosita. Can everyone hear me? Is it okay? Okay, thank you, Prof. Rosita, being the chairperson this afternoon under the webinar series on SDG, water and sanitation. This is my first time talking to the great, organization, especially on the United Nations of Environmental Program. Thanks also to Prof. Rahina, who has been calling me so many times, and then I'm not very familiar with all this, the internet and all those. I got problem with internet. And then, in fact, this morning also my wife helping me setting up this WebEx webinar. So welcome everybody. Welcome Dr. Puria. Nice to listen to your projects on the nanotechnology for water treatment, is it? So this afternoon I will talk on the, why could I share this? Can I share this?
Yes, please. Bottom share.
Bottom share, okay, now.
You can share your desktop or share. Okay, pass. We can
Okay,
see you.
is it okay?
Right. Yes,
Okay,
yes.
can everyone
Very
look?
good, very good.
Okay.
Very good, very good.
Good in the pictures, that's me. So
It's okay.
I'm Suhaimi. So I've been in the seaweed research for the past 20 years. So up and down to the field, and then give a lecture, and then what do you call capacity building, give training to the farmers and all those. So it is very challenging job when you talk about agriculture or aquaculture. The farming is the most critical, what do you call it, critical scope in agriculture. If you fail in the farming, you fail the whole value chains of the business of the commodity and whatnot. Okay. Right. We have three types of seaweed. This is the macroalgae, not the micro. Micro is single cell. This micro is big algae, a big size of what you call the chemical content, especially the carrageenan. Number one, what we call the green seaweed. Okay, especially the colopa, or normally people call it lato. You can buy in Lazada, you can buy in the market. Okay, so another term for this one is sea grapes or sea caviar. This is very sellable, good market. There's one of like a flower on the top of the sushi. That one is colored by this, very expensive. Okay, but it's found wild in Semporna and sell it in the market straight away. Okay, we don't farm this at the moment. Thailand and Vietnam, they are exporting this, as well as Philippines and Indonesia. Okay. Number two is brown seaweed. We have it in our waters, especially the sargassum. Okay. The main content of this sargassum is fucoidon. The chemical name is fucoidon. Normally, it's used in so fucoidon will help you in what you call in slimming your body, and very sellable in Philippines. Okay, the name is fucoidon. You can Google it. This is not, this is found wild in Sabah, but it's a big business in Batam. Okay, number three is the red seaweed. This is a lot. This is what we farm in Semporna, especially the Kappaphycus and Eucheuma. Okay, this is what we farm in Semporna, in Sabah. A little bit of history of the industry. Okay, we have various phases in developing industries. Okay, in early 70s, we just started on small trial. Okay, from the farmers as well as people from Philippines coming to Semporna and helping us in doing the farming. Then we look at the potential of this commodity. Okay, early 90s, we have a few investors from private sectors, and the government also initiate, okay, the programs, especially on the poverty reduction program. At the same time, we have a few companies setting up their factories in Sabah, Semporna, and Kuna. In phase 3, after 2000, so this millennium phase, Okay, we have a big setting up factories to produce downstream products, and the government is for the commercialization of the seaweed. And at the same time, the R&D has been established among the universities as well as the other research institutes like Macroalgae, SIRIM, and whatnot. And in phase 4, it's become the commodity as a new resource of Malaysian economy because the high value products. And at the same time, we invite the private sector to invest. The government only facilitate on the regulations, and the fund come from the private sector. Okay. Okay. Then we are committed in the whole value chain of the industry, starting from the R&D. Then we go for innovations, and then we have the lab helping the SMI to do the what you call the small and medium products, and we have commercialization. Right. Initially, we focus on R&D, but the government adapt the what you call the result. Okay. And on the new economic models, meaning to say that everyone must have, every family must have an income. We call it high income. That's the target for the government. And then inclusive means that everybody must participate. Okay, the universities, the public sector, the community, the government, and whatnot. And it must be sustained. For the business, it must think about the sustainability. Then the project is on until now. So everyone must have opportunities to what you call to make money. So we initiate the private sectors to invest, and for the past 10 years, we have about 20 private sectors investing in this project. Okay, with the government under the nation government, what we call aquaculture, under the aquaculture scope, what we call the community-based commercial approach of seaweed mini estates, starting from 2011 up to 2020. It's 10 years project. So at the same time, the government asked us, can we improve the poverty for the community? Yes. Then we do this, okay, helping the community to increase their income. So these are the calculations based on 1 hectare, because the government allowed one smallholders to have 1 hectare of area. And then they asked us how much they can from 1 hectare. Then we do the costing, we do the revenue annually, and then the income is about more than 2,000 ringgit per month. So this is above the poverty level in Malaysia. So for the national target, we are playing about more than 1 billion business, more than 1 billion ringgit business by 2020. So last year, for the 10 years lah, starting from about 200 millions and up to 1 more billion ringgit. So this is our GNI. So first question is it sustainable project? Yes, if you got the sun, if you got the ocean, if you got the water, if you got the moon, yes, it is very sustainable. So we are very fortunate. Sempurna, we are in the coral triangle area. So the world best biodiversity. We share the water body with Philippines and Indonesia. So we have very good sunlight, very fertile water, very good water quality because we got the coral reef, okay, the ocean, and then we have the movement from deep water to the shallow water. And then we have all the inputs. Okay, initially the seedlings come from Semporna. We can find the wild seaweed in Semporna, and then we have the people farm the seaweeds, and at the same time, we just manage all these resources to make money lah for companies. Yes, this is for a triangle. Okay, the two main varieties of seaweed we farm in Sabah. Number one is the Kappaphycus. This is to produce what we call the Kappaphycus, is the gelling agent. We eat this one every day, especially for the dairy and meat products. You have yogurt, if you have ice cream, carrageenan is there. If you have yogurt, if you have burger, you had hot dog, the carrageenan is there. So these are the binding agent to hold the water, protein, and fat together. Okay, this is the function of Kappaphycus. Okay, they can bind water and fat together. Another one is the Eucheuma. Eucheuma is normally found in your toothpaste. It's not the gelling agent, it's thickening agent. It's just like your corn flour. Okay, what we call the iota carrageenan. So we farm in Semporna as well. Okay, so these are the two big varieties farmed in Semporna. Right. The topics in the tradition and innovation. What happened last time, about 20 years ago, 30 years ago? The company reluctant to invest in this project because of all the perceptions. Number one is labor intensive. Yes, I agree with this. You follow the traditional method, 80% of your time, 80% of your labor spent on the oceans. Just farm and harvest, like this guy. Okay, I cannot stand in the it's too hot. Okay, then you go to Semporna, you go to Sabah, and you go to the seaweed farm. You must look. You must be seeing this kind of livings. Yeah, so just like a poor man industry. All right. Then number three, they don't follow any environmental programs. They just put plastic in the farm, in the sea, which is not allowed by the Sabah Park. Okay, and then in fact, we have discussed in Sabah Park. Then they asked me how to remove all this plastic, raffia, and all those from the waters because it's very dirty and then it's not nice to look at. Number two is this direct sun dry. You know what happened with you when you dry directly to the sun because the sun got UV. The carrageenan has a big size, it's about 700 to 800 kilodaltons. And then here, the UV can chop down your carrageenan into the small size, it's about 5 to 10 kilodalton, and become carcinogenic, can cause cancer. Okay? That's why we need to find the ways how to help the farmers. And then, if you look at the Semporna, and then you must look at the way they pack they pack the seaweed like this. Okay. So you just imagine this is your raw mat.
One more minute, Professor Jaime.
Yeah.
1 more minute.
Oh, thank you. Right. Okay. The challenge is, can we turn into this perception into business, and then sustainable, and how to make money? Yes. We developed the system, what we call the mini estate system, whereby we can spend our times more on the platform, rather than in the farm. So 80% of the works is on the platform lah, what we call the mini assay system. Okay, these are the complex that we have, the concept that we have. This one in Sempurna, we developed this. Okay, we have various varieties in Sempurna. It's more than 32, but the best varieties is this one lah. We recommend to the farmers. Okay, and then these are our nursery. Okay, you must have a nursery before we go for the commercial farmings. Okay, whether you got from the wild stock or from the existing seedlings. Okay, high density seedling. Okay, this is the land base, how we prepare the seedling from the plant heads. Okay, we start from 50 grams up to 100 grams. So our seedling is about 100 grams weight. We develop the type, okay, the ropes. We are not using the plastic bottle anymore and the raffia ropes. And then we develop the casino table rather than a lot of people sitting down there and very difficult. Okay, and then you can tie according to your time at night. Okay, we develop the fertilizers, but we must spray. We don't apply on the farm, on the seed. Okay. Then this is the eco-friendly tie as compared to this one. Okay, using the plastic bottle. Now we are using the more friendly materials, and then can spend about spend in life about 10 years. Okay, harvesting rather than manual harvesting. Then we go for the what we call the combine harvester. The dry, okay, instead of using open system, we develop a system what we call sauna and dry. Meaning to say you remove the water first, about 50%, then you dry it in this chamber, what we call natural convection solar dryer. And what about the quality? Okay, this is what happens. If you go to the farm now, there's a lot of plastic tie. And then the company will not buy if you have this kind because it's very dangerous for the foods. Okay, so we have, if you use our method, we got very clean dry seaweed. So packaging, okay, we ask them to do all the standard packaging with the label as well, especially on the moisture content. Okay, and that's all, Prof. Zita. Thank you very much. I hope it will.
Thank you so much, Professor Suhaimi. Very interesting and informative presentation from both speakers. So thank you so much. I think we are now in our Q&A session. I noticed there are several questions for Dr. Puria. I think there are 3 questions for you, Dr. Puria. So can we start with you first? Okay. Hang on, yeah. I see here someone asking about the efficiency.
Hold on, Prof. Rosita. I think Prof. Suhaimi need to stop. He's sharing.
I need to, what do you call?
Stop sharing.
Stop sharing. Where is it? Stop
Okay.
sharing.
Yeah,
I can't see anything from him now.
But I'm still viewing Prof. Suhaimi's.
Okay.
What is this? What is this?
The 3 small dots, I think.
At the share button at the bottom, maybe in yours is stop sharing or maybe hide somewhere.
Share.
And then unshare
Show
or
content or share?
don't share your content. You're done. Okay, great.
This one.
You're back.
Okay.
You're back.
Thank you.
All right,
Okay.
Prof. Rosita.
Okay, all right. So I will go to the first question, yeah. This is for Dr. Puria. From Monica Chin, yeah, Borneo. She asks about if the water filter system already being commercialized. I would like to know more, perhaps to provide clean water for community project here in Borneo, she said. So what is your response, Dr. Puria?
It's not thanks for the question. It's not commercialized yet. We are in the prototyping stage. We have built 50 prototypes. We tested the quality of the water, and then we sent it for the basically association of the water in Sri Lanka and also Singapore. So the
Sorry, I think you are breaking up. I'm not sure if others can hear you clearly. Did you get the answer, Monica? Is that are you mute, Dr. Puria? Your speaker is on?
yes, my
can't
speaker
hear.
is on.
Now it's okay.
Okay.
All right.
So yeah, just to make it quick, yes. So we have done some preliminary prototyping, and then they were successful. So we filed a patent, and we are in a stage of producing hundreds prototypes now. We want to test the quality of the water in Cambodia as well, and and we also want to improve the efficiency of some of the heavy metals, because they are in a stage of like 98, 97%. So it will be, we are looking for investors for the 100 prototypes, and then we can focus on a specific area, because as you know, the quality of the water would change basically the efficiency also. So we can tune up the technology based on the quality of that area.
Okay, thank you. So it's not yet commercialized, but
No,
I also noticed that your cost is much cheaper than, the one
yeah,
available in the market with different technologies, which is a very
exactly.
good news to me. So,
Yeah.
okay, I hope that answer your question, yeah, Miss Monica. Okay, I move to another question. From Lim Potek. He asks you about the hang on, yeah, efficiency of the of your filter. How long you need to hang on, yeah, I lost the question. How many times the Poseidon filter able to filter the water before it is replaced?
Yeah, it's capable of filtering 1,800 liters of the water, and the expiry date is 1 year to almost 1.5 years. We are working on extending the expiry, but the filtration capacity is 1,800 liters.
I see. Okay. So meaning it depends also on the condition of the water that you're going to filter.
Exactly.
But roughly it's about a year for normal maybe condition,
Yeah,
normal water
exactly.
condition. Okay, thank you. Okay, I have the third question. Hang on, yeah, I need to look for it. I think that's all. Did I miss anything for Dr. Puria? Yeah. Yeah, I think that's all from Lim Potek. Okay.
Thank you.
Okay, thank you. But you still can put your question in the chat box, and also we are also putting a Google form for you to fill in for your attendance, yeah, in the chat box. Okay, now let's go to question for Professor Suhaimi. This is from Ernie Muhammad. She asks about, okay, is the seaweed that you farm is locally called lato?
Okay, Ernie, this is not lato. Okay, this is a commercial farm in Sempurna. We only farm 2 varieties, what we call Kappaphycus and Eucheuma denticulatum. Lato is the color part, the green seaweed, and then we found a lot in Sempurna in Sabah, but normally people take it from the wild stock lah. Okay, we don't farm this. Okay, especially people eat the Colopa lentilifera, not the samosa. The diamond type, what we call, okay, the coastal people call diamond type of lato, or sea grapes, or sea caviar. Okay, so we don't farm this, and then we got it from wild and sell it in the market. Okay, wet market. All right. I hope I answer your question.
Okay. And then we have a question from our speaker also, Dr. Puria. I have question for Professor Jaime. Does the salinity of the water affect growing the seaweed? Can this be done in saltwater lakes too?
Yes, Ernie. Okay.
This
This
question
seaweed,
is from Dr. Puria.
oh, Dr. Priya. Okay. Okay, Dr. Priya. Yes. Okay. This type of seaweed, what you call the microalgae, you must the salinity is affect the growth. Normally, okay, our seawater we have about 27 to 33 ppt, so we can grow on this. Okay, so there's a parameter of the salinity lah.
Okay, thank you.
Okay.
Thank
All
you.
right. Another question for Dr. Puria. Yeah, this is from Rafin Zakaria. He said, can you share a little bit on the efficiency of this membrane filter in removing of dissolved in organic pollutants?
Sure. I had like long slides of showing the efficiency, but I didn't show. I think I had to put them back. But in general, I can say that, for example, what we didn't and we haven't tried yet is the fluoride. So we haven't tried the fluoride. That's something that we are trying to do at this moment. But other types of organic pollutants, for example, BPA, we tried the BPA and we are having 98% removal of BPA. The benzene, we are having 98% of removal of benzene. The virus, we have tried just one type of antiviral efficiency, but it's not the real virus. It's a basically simulation of the virus, and we proved that we can remove the basically particles up to 100 nanometers. As you know, the size of the COVID virus, for example, is about 90 nanometers. So it's 90 to 150 nanometers is the size of the COVID virus. So we proved that we can remove any virus beyond 100 nanometers. So yes, we have tried different types of heavy metals, organic pollutants, but not all of them. We are in the process of filtering and assessing the different efficiency. But antibacterial and antiviral, we are done, and it's proved.
Okay, thank you. I hope this answer your question, yeah, Mr. Rafi'in. We have question from Professor Rahina herself. This is to Prof. Suhaimi. Yeah? How many integrated centers have been built in Semporna, and how many people are working and living at one time?
Okay, Prof. Okay, I've been working on this since 2000. So the centers, I think quite a few since 1990s. Okay, one you have in Pulau Bangi. That one is under UMS and LKIM. And then a few in Tawau. There's one big farm invested by the Taiwanese, quite $1 million. He is investing on this project. And then another complex is under Jabatan Perikanan, Fisheries Department of Sabah. Okay. Then we go back to the Semporna, quite a few. The big one is in Pulau Omadal. Okay. And then people, the participant is about 50 to 100 participants. In in Pulau Bangi, we have about 100 participants. In Tawau, they got a big complex. Okay, they have got a hostel involving about 100 workers. Then another one under Yayasan Sabah, in Sabah, involving about 150 to 200 participants. And then Pulau Sebangkat under Lembaga Kemajuan Ikan Malaysia is about 200 and 300 participants. And then Persatuan Peladang is about 300 to 400 participants. And Kuna, that's got one complex, is about 100 to 150 participants. Lahad Datu, if I can recall, Lahad Datu, near the war area, the Tanduo, okay, the war zone is about 100 participants, bro. There's a few, okay, since early 90s. There's a complex, a big complex. Pardon? And then your next question is?
I think you have answered all of them. She was asking about how many people are there living at one time. I think you've covered that, right?
Yeah. You're right. Normally, for the Taiwanese farm, okay, they put people in a complex. It's about 100 people staying there. But the others is the local communities, okay, working on the complex, okay, so that they don't need to build the hostel for them, only in Tawau, the Taiwanese investors. Okay, the one you remember, the kidnapping case in Pulau Sebangkat Semporna, that one is a big complex under the big company. So that involved the community around 250 and 300 people involving in the projects. So it's quite a big project, bro. If I can answer you lah. There's nearly 50 to 300 or 400. Okay.
Okay.
That's the what they call the community projects lah.
Thank you. I actually have a question in relation to this. What is the status, the latest status to this project that you've just mentioned just now? Are they still the same, or duplicating or anything like that? And what are the challenges they are facing?
Okay. The big challenge now, bro, is the what they call MCO. Okay. So since last year, 2020, the people is no longer farming seaweed. No longer farming seaweed, only a few acres. Okay, only a few acres. Because of the MCO, and then they scared about the disease and whatnot. But the government still building up the complex under Jabatan Perikanan. Okay, building up the complex. But we are waiting for next year. Hopefully, people will start planting, farming seaweed lah. So at this moment, I can say it's about, we have total area 36,000 hectares. So the planting area is about, I think it's about 1,000 hectares to 2,000 hectares. Not many anymore, because I have a survey with all the buyers. So they don't have any stock anymore. So we wait for next year lah, Prof. So it's very sad because of the MCO. Yes.
Rosita, Dr. Korea need to leave. Yeah.
Thank you so much.
Thank you, Prof.
Thank you. It was a pleasure to be here. Thanks for your invitation.
Welcome.
Bye.
Bye.
Please unmute, Dr. Rosita.
Cannot hear you.
Please unmute.
We have only 4 minutes left, and I think we can entertain the last question from Ms. Monica. Yeah. Prof. Suhaimi, is there a possibility to collaborate to support my community project in West Coast Sabah as we try to divert fish boomer? I think onto other than we train them to be citizen science to preserve the coral reef through our education and awareness program.
Yes, you can. If you are willing to work with the community, okay, we can help you. Okay, dealing with community to what do you call to avoid of the fish bomber lah. Because I have a farmers also. He is a fish bomber now, no more already. So I think this is a good project. And then at the same time, you preserve the waters. We need seaweed to be planted in Semporna to preserve the coral, because there's symbiosis between the sea livings, the coral, the plants and whatnot, with the seaweed. Okay? So this should be no problem.
Yeah, it's a
So we
yes.
can
Yeah, Miss Monica,
assist you.
it's a yes. So later on, you can get Professor Jaime contact number. Yeah.
Okay.
Okay. So I think if you have other question, you can still type it in the chat box, and later we can respond to you either via email, or if you want to stay a bit longer, also we allow you to do so lah after the 4 p.m. Okay. So we have now come to the end of our 6th webinar series on SDG6 water and sanitation, co-organized by UNEP and ACT Malaysia with UPM, University Putra Malaysia. I hope everyone has gathered some new information, as we have been enlightened by the talks and discussion in this last 1 hour. Today we covered SDG6 topic on increasing water resources through smart technology and improving traditional seaweed farming for commercial opportunities. And I am pleased to remind everyone about the next upcoming webinar series number 7 on the 1st October 2021. The webinar number 7 will focus on monitoring and management of water pollution for communities' resiliency. So until we meet at the next webinar series number 7 on the 1st October 2021. We pray that everyone is safe and healthy. So love your environment and prosper your community. Be safe and stay safe. Thank you, everyone.
Thank you.
Thank you, everyone. Monica, do you have to go soon?